Hello, today I'm going to show you how to determine whether the following series is divergent or convergent. And the series is sigma 1 divided by e with the power of n plus 1 divided by n times n plus 1, when n varies from 1 to infinity. Okay? If you calculate the limit of this term when n goes to infinity, that will be 1 divided by infinity, which is 0, plus 1 divided by infinity, which is 0. Therefore, it will be 0 plus 0 equal to 0. Since the limit of an is equal to 0, the series may or may not be convergent. So that test is not useful anymore. That test is useful when the limit is not equal to 0, or if it does not exist, then you can conclude the series is divergent. But now in this case, since when n tends to infinity, the inside the parentheses will be equal to 0, therefore you cannot conclude anything. So you need to find a different method. So let's rewrite this sigma as sigma 1 divided by e with the power of n when n goes from 1 to infinity, plus sigma 1 divided by n plus 1 and n times n plus 1, n changes from 1 to infinity. Okay? So let's evaluate each of these series separately. The first one, sigma 1 divided by e with the power of n changes from 1 to infinity, is basically equal to, if you put n equal to 1 here, that will be 1 divided by e, plus now 2, 1 divided by e2, 1 divided by e3, and so on. Okay, and that is a geometric series. Okay, and we know that the geometric series. So here this is a geometric series with the multiplying factor of 1 divided by e, because each term is equal to the previous term times this factor 1 divided by e. For example, let's look at this one. This term is equal to the previous term, that is 1 divided by e with the power of 2, times 1 divided by e, which will be equal to 1 divided by e with the power of 3. So, and we know 1 divided by e is less than 1. And for geometric series, when the multiplying factor is less than 1, we know that the series is equal to Sn equal to a, that is the first term, divided by 1 minus r. Okay? And I have a video about this one, how to derive this equation, so you can look into that video if it is not clear for you. Okay, so here in this case, a is the first term, that is 1 divided by e, so 1 divided by e, divided by 1 minus r, and r here is 1 divided by e. Okay, which will be equal to 1 divided by e divided by e, that will be e minus 1, this will be out, that will be equal to 1 divided by e minus 1. So which is equal to sigma 1 divided by e with the power of n, and changes from 1 to infinity. So we could now evaluate, we could now compute the first term here. So now the challenge is the second term. Okay, so for the second term, so sigma, you can write sigma 1 divided by n times n plus 1, n changes from 1 to infinity. So here again, if you calculate the limit of this term, the inside of this sigma, when n goes to infinity, that will be equal to 0, so it will not be useful. So we can actually compute the partial summation Sn, which will be equal to sigma, let's write it I times I plus 1, when I changes from 1 to infinity. Okay, and that term here, the ins 1 divided by I times I plus 1, using the partial fraction decomposition method, you can write it as 1 divided by I minus 1 divided by I plus 1. Okay, so from here you can write this fraction like this. And if it is not clear for you how to get from here to here, just leave a comment for me in the comment section and I will show you how to do that. So here I changes from 1 to n. Okay, so now let's expand this series. So if I is equal to, let's say, 1, the first term will be 1 divided by 1 minus 1 divided by 1 plus 1 will be 2. Plus now I will be 2. So that will be 1 divided by 2 minus 1 divided by 2 plus 1, that is 3. Plus, for example, I will be 3, that will be I divided by 1 divided by 3 minus 1 divided by 3 plus 1 is 4. And that can continue. Plus, until I will be equal to n. So that will be 1 divided by n minus 1 divided by n plus 1. Okay, so as you can see here, this term is out by this term. This term is out by this term. And that continues actually. And this 1 divided by n will be cancelled out by the previous term. So all which will be left will be equal to 1, the first term and the last term, minus n plus 1. Okay, so this is equal to Sn. Okay, so we know that the sigma 1 divided by n plus 1, when n changes from 1 to infinity, is basically equal to limit Sn, okay, the partial summation, when n goes to infinity, which will be limit, here we calculated 1 minus n plus 1, when n goes to infinity, which will be equal to 1 minus 1 divided by infinity is equal to 0 is equal to 1. 1 minus 1 is equal to 1. Okay, so now if we go back to the first series, the question basically was the sigma 1 divided by e with the power of n plus 1 divided by n times n plus 1. Okay, when n changes from 1 to infinity. So the first term we calculated, and it was equal to here it was equal to 1 divided by e minus 1, and the second sigma, and the second one here we just calculated and it's equal to 1. That will be 1 divided by e with the power of n. That is this one, and this term, the second sigma, was equal to 1. Okay, which will be equal to e minus 1, that will be 1 plus that will be e minus 1. This is out, this will be e divided by e minus 1. Okay, so that means this series is convergent, and it will be equal to e divided by e minus 1. I hope you found this video helpful. If you are interested, please feel free to subscribe into this channel so that you get updated when I upload new videos. Thank you.